In the last video, we talked about the complex system of entities that affect phosphorus flow. So, what is a silo? A silo is a term for a unit within a system that is isolated from other units within that system. This could be a department within a single business, a college within a university, a branch within a government, or even an entire sector of the global economy. Take the example of a department in a business. To be considered a classic silo, that department would have its own unique objectives, trainings, and goals. Workers might have little communication or sharing of responsibilities with other departments. Even if they would have friendly conversations with outside workers, they wouldn't be asking them for help with their work, because after all, as silos, they would be working on entirely different things. Siloing at its core is a lack of collaboration and intercommunication. It's often exacerbated by cultural, linguistic, and knowledge barriers between fields. In some cases, siloing may actually help a system work efficiently, like a machine. However, it can also make it more difficult to handle problems that fundamentally require collaboration, such as phosphorus sustainability. There are many contributing factors towards silo formation, but causes can be broadly grouped into two categories. First, silos may be caused by differences in mandates and responsibilities. For example, the TSA has a completely different mandate from FEMA. Both have entirely distinct responsibilities. When the two are required to work together, like they did during the Hurricane Katrina evacuations, there may be conflicting missions and priorities. Differences in goals and traditional approach may contribute to siloing. In our example, the mandate of FEMA was to safely manage the response to the disaster and mitigate human harm, which led to the goal of evacuating people as soon as possible to places with electricity, food, and running water. The TSA mandate, however, was to enforce flight regulations and flight security, which led to the goal of screening evacuees as thoroughly as possible and providing on-flight security. Evacuations were thus delayed due to screening procedures and the wait for additional on-flight personnel, and metal cans provided by FEMA were actually discarded by the TSA due to their inadaptability from these typical procedures. Differences in knowledge, information, and disciplinary culture or attitudes can also contribute to silos. This can even include variations in language and terminology. Think, for instance, how the difference between the meaning of the terms theory and law relative to a scientist as opposed to a legal scholar. The word evolution is often used differently in anthropology than it is in biology. It might be difficult for a microbiologist to have a conversation with a geographer about the landscapes of Estonia if they can't quite remember where Estonia even is on the map. And it might just be as tough for a geographer to converse with a microbiologist about mutations in chloroplast morphology if they didn't know what a chloroplast looked like to begin with. The organizations of academic and governmental institutions can also pose structural challenges to dismantling silos. Funding, for instance, is often divided departmentally and may pass through a long chain of officers before it reaches its final recipient. In research and academia specifically, positions, funding, program and grant applications, and degrees are virtually all divided by discipline. Academic journals are often field-specific and peer-reviewed by those in that field. This further discourages interdisciplinary publication because of potential knowledge gaps or conformity to disciplinary orthodoxy. The influence of prominent experts on publication, funding, and general acceptance further encourages discipline-specific conformity. Because publication is often a necessity for academics and because funding is a prerequisite for most research activities, researchers are then incentivized to stay firmly within their discipline and avoid deviating too strongly from traditional approaches. These structural and institutionalized barriers, combined with fundamental differences in knowledge, experience, and methodologies, serve to make collaboration across and beyond disciplines difficult. As previously demonstrated, phosphorus is affected by many government entities at all levels of scale. Its problematic and beneficial manifestations span numerous research fields. In order to study and solve problems related to phosphorus, it is essential for many fields to overcome silos and work synergistically and through interdisciplinary measures.